Hey everybody, good morning and welcome in. We're going to get started going here, building a couple of the parts that we're going to need for our automata. First up, make sure you are set up with a project file for this assignment. All right, if you made your box the other day and you did not put a project folder together for it, please go back in, create a folder, and then move your files from where you stored them previously into that project folder. If you don't have these projects set up, it's going to cause you a lot of heartache at the end of this project, okay? So please go in, get yourself an automata file set up, and have a project folder ready to go. If you're not sure how to get the files from wherever you saved them into this new project folder, let me know. I've got a video that I can walk you guys through moving files via the File Explorer in Citrix to get things moved around as you need it. All right, so I'm going to start a new part. And I'm then going to go ahead and I'm going to close this out so that I can go in and use my vertical tiling. I've got my new part on one side, I've got my drawing on the other. Ain't it grand? Okay, so first up we're going to do is what's known as an eccentric cam. An eccentric cam is simply something that the center of the profile and the center of the axle or that's driving this cam are not in the same spot. We've offset this slightly so that the cam itself is able to move and displace at a further distance than it would if it was all in one center point. So first up, real easy, sketch, grab my XY plane, main profile. We're looking at a diameter of 0.175. Center point is always my first click. Great. Now I need to draw this other circle here, diameter 0.255. Doesn't matter where I draw this to start with, because I am going to rely on my constraints to lock it in where I want it. Grab my vertical constraint. I want to vertically constrain the center of this circle with the center of this circle so everything rolls in place. Last piece I need is I need to offset the center of these by 0.375. Center point, over 0.375. Hooray. Letter E to extrude. Click my profile, 0.125. And there it is. Hooray. Now I can save this in my my automata folder, automata, and I've got 2020 because I've gone through this a couple of times. And this is going to be my eccentric cam and get my initials on there. All right, one down. Number 2. Now I need to do what we call our pear cam. So on our eccentric cam, when we run this around, it's going to give us one type of movement. It's going to be a consistent up and down. When we look at our pear cam, you can see that profile is different. It's going to go up and down, but it's not at an even pace. It ramps up and ramps down, as opposed to a consistent up and down. All this time it's at one distance, ramps up, ramps down, consistent distance. And we're going to do an activity specifically based around the types of motion that these different cams are creating. So don't get too stressed about that. All right, XY plane. Starting with our main circle here, we're going to have a radius of 0.75. So my diameter is going to be, oh, I missed my dot. 1.5. And I need to make a circle for the top here. It's got a radius of 0.25, so I need a diameter of 0.5. Line up my centers. 1, 2, there we go. Distance between them from the center of this one to the center of this one is 1 inch. So I'll grab my dimension tool, center point, 1 inch. Yeah, it looks like they're really close. That's because they are. Line on one side, right click, create line. Line on the other side, great. And now it's time to tangent these. 1, 2, 1, 2. Now I'm ready to go ahead and trim this down. That's right here in the modify section. Grab my trim tool. I can get rid of anything that I'm not going to need in my final geometry. And anywhere these edges come in contact, it creates a cutting plane. You right click, OK. Move this over just so I can see. So you can see my profile here and the profile here, they match up pretty well right now. I can take and delete those. Last thing I need to do is draw this in, and this hole and this curve have a shared center point. So I should actually have a center mark on there that shows that all of those centers are together. Circle, magnet, 0.255. There we go. Extrude, 0.125. And there is my pear cam. File. Again, 2020 folder. Pear cam. Initials. Closed. Okay, this one looks a little intimidating when you get started with it. This is literally the exact same thing as your pear cam with one little circle extrusion added on. So let's make a new part. Square them up. Go. First circle. Radius of 0.375. So I'm just going to simply say 0.375 times 2. 0.75. There's that. My other circle is 0.234. That is my diameter. So I've got another circle to draw up here. 0.234. Make sure everybody lines up. And our offset distance is 1.15105. Nice, simple, logical, easy sizing to remember. 105. There we go. Line drawn. Line drawn. Tangent. There we go. Trim. You go away. And you go away. All right. Last piece I need to get is this hole for our axle to go through. Looking at a notation that you have not seen before. All right. When we're dealing with holes, we normally do not want to just use our normal dimension tool up here to mark that, like we would with the rest of these radiuses and lengths and things like that. For a hole, we like using this hole and thread tool so that we can list out not only the size of the hole itself, but in this instance, how deep that hole goes. So it's a 0.65 diameter hole that goes down 0.3 inches. If we look over on the right side view, we can see that 0.3 inches is our full thickness. So this is what's known as a through hole. So sometimes you'll see this listed as that dimension, and then the letters THRU, like drive through, as a through hole. In this instance, it's just telling us the depth, which is fine. But I need to add that hole in, and I can see my centers line up, and I want this to be 0.62. 265. There we go, and I'm ready to extrude. And this is a thickness of 0.3. There we go. The last piece is to add in the handle for the crank. So we're going to add a sketch onto that surface. And I can come up here, grab this circle. So I project that geometry. It's going to give me that little dot right there. That dot is the center of this arc that we used to create it. So click on my center mark, come out to the edge, and I extrude that up the 0.956 that we see here. And there's our crank. Saved. Gone. All right. The next two sheets that are on here. If I need to walk through with you at this point how to make a 5 3/4 inch long, 1/4 inch diameter rod, that's a circle and extrusion, or a little trickier, 1/4 inch square and a 4 inch extrusion. I'm not walking through each of those at this point. You guys know how to do that, no problem. Last up is what we call our guide. So the tricky thing when we deal with these cams is that follower is moving up and down, and it's going through an opening, but we need to make sure that there's not room for that to flop around and go off to the side and get all kilter. So what we do is we insert these guides here that allow that to stay straight up and down, keep it true. So what's also called a bushing, depending on what industry you're working in. And again, it just keeps things aligned so the bores stay centered. This one, real easy, but we're going to go through it just to make sure everyone's on the same page. There we go. I'm going to start with the bottom portion of the Super Mario World Warp Tube. There we go. And this is telling me my diameter here, because this here is this. This circle is the same as this circle here. They're identifying the same aspect. And that happens to be 0.4375. There we go. And it's 0.375 in length. Now it's time to add in the top lip. That one happens to have a diameter of 0.575. And an extrusion of 0.125. Last piece, I need to draw in this rectangle so that we can extrude that out. I'm going to start, and I'm going to use this 2-point center rectangle. That way I can start from my center point and know that I'm perfectly lined up in here. So one click on the center. I'm going to just move my mouse out and away. 0.25, tab over, 0.25, enter. So my center points are aligned, and I've got my equidistance. E to extrude. We're going to cut this out, and we're going to go all the way through. And there it is. There is my guide. All right, we're going to have some more pieces coming tomorrow as we talk about how to assemble all of this together and to measure the output of our cams. So tomorrow we're going to look at when that cam rotates, how far does it move that follower, and how can we design that for a specific outcome that we want, as opposed to simply just making a cam and being surprised by what we get. All right, take care of yourselves, everybody. Be safe, and I'll talk to you soon.